Find the derivative using the limit definition and algebra. So in this case, we are not going to be using tables or estimations. We're using this big machine called the definition of the derivative. Here we have a equals 1, a specific point. So we need to substitute in a equals 1 into that definition of the derivative. I'm doing that here. Now the big algebraic task is find f of 1 plus h. And that requires us to put 1 plus h into the function 2x squared plus x. So think of x as the input, and whatever is placed in the parentheses after f goes into those spots wherever it says x. In our case, it's 1 plus h that's in the parentheses. So we repeat that wherever x appears in our function notation. Remember that 1 plus h squared is 1 plus h times 1 plus h, and you have to FOIL the whole thing out, so that's what I'm doing in this next step. By FOILing, we get 1 plus 2h plus h squared. Now remember that extra 1 plus h on the end. Now let's multiply the 2 through, distribute the 2, and we're getting 2 plus 4h plus 2h squared, and we still have plus 1 plus h. And what we see with a little rearrangement is 2 plus 1 is 3, 4h plus h is 5h, we have 2h squared. So this is the value of f of 1 plus h. And that will go here in the first part of that difference quotient. Time to go back to the limit definition of the derivative, rewritten here. But now we know what f of 1 plus h is. So we're just going to insert that in. We've got 3 plus 5h plus 2h squared. That was our work above. And that replaces f of 1 plus h. Now let's subtract off f of 1. 2 times 1 squared plus 1. And make sure that that's put into a quantity, because all of that is f of 1 together. There's a few simplifications that we can perform in the numerator. So we start with simplifying f of 1 to be just 2 plus 1. But 2 plus 1 is 3. So we really have in the numerator 3 minus 3, and then we write the other two terms, plus 5h plus 2h squared. But the 3's cancel. So let's eliminate the 3's in the numerator, rewrite, and let's look to factor in the numerator. What's in common between 5h and 2h squared? It's h. So we are going to pull h out and factor by GCF. H comes out, and we have then the h above and the h below, which cancel. That's good because ultimately we want to be able to plug in h equals 0. Let's see what we have left now. Looking at this, we don't have a 0 in the denominator if I plug in h is 0. So we'll just plug in h is 0 at this point. We evaluate and we get 5. So 5 is f prime of 1, which is the slope of the tangent line at x equals 1. We could also say that it is the instantaneous rate of change at x equals 1. So we found the derivative using the limit definition and algebra. Thanks for watching, and stay tuned for more great math videos.